Hey everybody. So in this example, we are looking at a shift in substitution cipher problem. All right. Now, remember the goal of this lesson is to continue to work on our problem-solving skills. So we have kind of three techniques that we've been using. So the first is using this input processing output model of problem solving. And we learned also that we should probably be trying to break a problem up into kind of more manageable pieces and kind of code each one of those pieces as we go and kind of do the IPO method and the software development lifecycle with each one of those. So we can code it, we can test it, we can adjust to make sure that it's working properly before kind of moving on to tackling the bigger full problem. We don't want to just code everything all at once and then test at the end and try to take a long time trying to debug what is not working. Right? And in this lesson, we're adding functions to our code. So with those manageable tasks, we have to look at maybe there's kind of a better way to write the code rather than kind of one big function. We can kind of break things up into little smaller pieces and then use those to kind of fit together to solve the larger problem. All right, so maybe a few things before we start looking at how to solve the problem is you kind of need some definitions of what everything is. So we've got something called a plain text message, and that's just kind of the normal English version of something that you're writing. You have something called ciphertext, which is a scrambled up version of that plain text message. And we have the two words to encode and to decode, meaning to change plain text to ciphertext or to change ciphertext back to plain text. All right. So we're going to look at a very simple cipher where when you encode or decode, you're just applying a shift of the letters. Okay, so if you were to say take a message and decide to shift all the values by 2 letters, then the letter A would become the letter C, the letter F would become the letter H, and the letter Z becomes the letter B. All right, so all you're doing is basically exactly what it says, shifting each character to the right in this case by whatever the shift value is. And if you get to the end of the alphabet, then it kind of wraps around to the start again. So Z, because it's shifted by 2, would start at the beginning of the alphabet and go through A and B would be your shift of 2. Right? And the same would work for decoding, except it works in the opposite direction, where you just go to the left instead of the right, right? So if you're encoding, you pick a shift value, you shift all the letters, and then you get a scrambled up message that doesn't make any sense. If you're decoding, what you need to do is you need to know the key, right? Or the shift value that was used. And once you have the shift value that was used, you can then just shift the letters back the appropriate number of spaces, and you'll get the correct message at the end. Okay? So in terms of like some examples here. So here we have, say, a plain text message, say, the force be with you, may the force be with you, and show me the money. And I believe I used a shift value of 5 for both of these messages to create the ciphertext. So here is your plain text, okay, in the green, and then your ciphertext is in the blue. Okay. So just a couple examples of encoding here, and you can tell the shift was 5 because if you're going from M became an R, so you'd shift M to N O P Q R is 5, okay, and S to X is T U V W X. That's 5. That's 5 shifts. Okay. Now with decoding, you actually, in a substitution cipher like this, in a shift cipher like this, we actually don't need to know the key. You don't need to know the shift value because there's only 26 possible different shifts. So that's not actually hard to use a loop to kind of generate all the different possible messages with. So for example, if I had this ciphertext here, and I wanted to decode it, and I happened to know that it was likely a shift cipher, I could just try all different shift values. So shift of 1, 2, 3, 4, 5, 6, etc. and just print out all the different possible messages. And it's very likely that it doesn't take that long to scan, right? And you can find the only message that makes sense. So this ciphertext decoded to "you had me at hello," and then this other ciphertext here decodes to "hit me baby one more time." Okay, so that's what we kind of want to do in this program. Is we want to basically, I guess, two programs in one. We want to write a program that encodes based on a specific shift value, and then decodes all the possible different shift values. Okay. Now, in order to make it a little more interesting, I guess, in order to decide what the shift value is going to be, we're going to use a shift that will be determined by the character that appears most often in the plain text message. Okay, so if you had if your plain text message had the letter E being the most common, then that would result in a shift value of 5, because E is the 5th letter in the alphabet. Okay, and the tie goes to the letter closer to the end of the alphabet. So I mean, I could have written it so I just entered the shift value from the user, but let's make it a little more complicated and do it like this. This is, if you're looking it up, it's there's a name given to this. It's called the Caesar cipher, and the letter E is the most common letter used in the alphabet. You can actually take a look statistically what letters are most commonly used in words, and E would come out on top of all of them. Okay, so that's kind of like understanding the problem here, what we're being asked to do. It's going to be a whole other story to kind of try to code this. So let's see what we can come up with our problem solving for that, and kind of figure out a starting point. So what I found is a kind of a good strategy with these shift and substitution ciphers is to create what I call a mapping alphabet. Okay, so we have our normal alphabet, and let's maybe think about it as just like a string of all the letters in the alphabet. So I'm going to use this lowercase here, just because it's easier, but you could deal with that in your code by using the dot upper, dot lower. So you got all your characters in your alphabet, and it's going to be just one kind of big string, no spaces in there. Okay, and then what we're going to do is we can create a new alphabet based on the shift value that we wanted. So if we say wanted a shift value of only 1, then A would become B, B would become C, C would become D, E, F, G, etc. Okay, and then you'd have Y, Z, and then Z would wrap around to the start of the alphabet and become A. Okay, so how you would use that is it's called a mapping because it tells you what letter belongs to what letter in the new or the old message. All right, so if we're encoding, okay, we have a message, okay, right, that we want to encode, and what we would do is basically we would go through this message and find where the A was, okay, and then we would look for where the A was. We'd look for what letter A actually is. Okay, so right, A would become a B, right? And we could replace the A with a B, and then we would do the same thing for every letter in the message. So you're basically, right, just creating a pointer to where these letters belong, right? So that's if you're encoding. If you're decoding, right, you're just going the opposite way, right? Decoding. Okay. So you have your cipher text over here. I guess it should be plain. All right. You're going from your cipher text to your plain text. This new alphabet is what matches the ciphertext. Okay, so when you decode, right, you would look for, say, the E in the decoded message, in the ciphertext message, and then you would know that that would really represent a D. Okay, so if you want to decode, you can just go the opposite way, right? And this would be a good place to start because it's used for both encoding and decoding. So what we could do is we can take, or we could write a function, I guess, that, so maybe call it like a map function, right? And that function would need the normal alpha. Let's call it the, since we're going to be changing things, let's call it like the old alpha, the new alpha for my new message, and then the old message would be the three things that we would need to send into that function, and this would just return a new message using the new alpha. Okay, so how this would work is if you're encoding, okay, you would send in as the old alpha the normal alphabet, because you're starting with a plain text message. So your old message would be the plain text, your old alpha would be the normal alphabet, and your new alpha would be the shift. Okay, so you'd send in the normal alpha. Maybe this would be better as the shifted. Okay, so you're sending normal alpha, you're sending the shift alpha, and you're sending the plain text to it. Okay, if you're decoding, right, you're going to send in the shifted alpha, and you're going to change it into the normal alpha, and you're going to send in the ciphertext. Okay, so we can use this mapping function twice for both our encoding and decoding, right? And then I suppose we could write a function for each one of these. The encoding one would have to search the plain text message for the most frequent letter and then generate the shift. Okay, so maybe we'll map. Okay, so our encoding one would search the plain text for most common letter, and then we got to figure out a way to generate the new alphabet or the shifted alpha. All right. Then create shifted alpha. Okay, where the decoding, okay, would use all possible shifted alphas. Okay, so we would just use a loop in our decoding algorithm to send in all the different possible shifted alphabets with a shift of 1, 2, 3, 4, 5, etc. Okay, so I guess maybe three functions we'll have to write. This mapping function, which will do most of the work, the encoding, which will find the shift value we need, and then we'll create the shifted alpha from that, and then the decoding will look at all the different possible shift values and create the shifted alphabet to send to our mapping function. So that's kind of my strategy. It's going to take a while to do. It's not easy at all, but let's see if we can make it work. All right, let's take a little bit of a closer look at what we would need to do to create this mapping function. So I'm going to use one of the examples that I already had. So my plain text message was, "May the force be with you," and I want to encode it. So I'm going to go from my normal alphabet to my shifted alphabet, and I'm going to pick a shift of 5 just for my example here. So what this mapping algorithm needs to do is it needs to take the plain text message, and we have to go through every character in the plain text message. And what we're going to do is we're going to build a new Cipher text message from scratch. Okay, so every time through the loop, it's going to add a new character to the Cipher text message. And when we get through all the characters in our plain text, we will have the entire Cipher text message created. So we need some type of loop for that. So we loop from 0 to the length of the plain text message. Now remember, this is going to work backwards as well, so this could be the Cipher text message too. So maybe we'll call it the length of the old message. Not odd, old. So the message we want to change. Okay, so we're going to go 0 for the length of the old message, and we're going to have a new message that starts off as just a blank string. Okay, so just basically an empty string. Okay, and what we do is, okay, so I look at the very first letter. That's at index 0. That's my counter, right? So let's say my counter variable is I. And I'm going from 0 to the length of my message here. So my counter is at 0. I'm looking at M. Okay, so what I need to do is I need to find the index value of the M in my normal alphabet, because once I know that index value, and the shifted alpha has the same amount of characters in it, so the index of M here is the same as the index of the letter that I actually need in my shifted alpha. Okay, so I need to find the location. All right, so I need a location variable of my old alpha, right, of the letter that I'm looking for. So there is something that I don't think was mentioned actually in the strings note. There is a method, or sorry, a function called find that will actually do this for me. So if I take my old alphabet and I'm finding, I can find any character I want in it. So if I were to put, say, like M in there, it would return the index of where the M is. Okay, I don't want to put just a normal character in there. I want to put each letter of old message as it goes through the loop. So I would need like old message at the counter. So the first time through the loop, right, the counter is 0. So old message at I is the M. Okay, so find M. The next time through the loop, my counter points to the A. So old message at 1 would be A. Okay, so find the A's location. Okay, and then basically what we would do is once we find its location, we can say like new message equals new message plus the new alphabet letter at the specific location that we found. Okay, so what happens is, right, we go through, okay, my I is 0, so I'm looking at the M, right? I search the normal alphabet for an M, and then I store that location, and then I look at the shifted alphabet's location at that same location, which is an R. Okay, so my new message was blank, and I'm going to add an R to it. So now, after the first iteration of the loop, my Cipher text message is just R. Okay, and now I do the same thing again. My I counter is increased to 1. So now I'm looking through the old alphabet for old message at I, okay, which is an A. Right? I look at the A, right, and I know that that is an F. Okay, so my new message, which was R, I'm going to add an F to it. So now it becomes F. All right, and now I do the same thing again. My I becomes a 2, so my old message at 2 is the Y. Search for the location of the Y, which would be 24, and then I look at my shifted alpha at 24, that's a D. Okay, so my new messages are F. I'm going to add a D to it and overwrite. So this becomes a D. Okay, and now I have a slight problem with my algorithm because I've encountered a space, and I have no space in my my alphabet here. So I could either add a space at the end, okay, and I could add it for the shifted alphabet as well, or I could just use some type of if statement to deal with that. Okay, so I could have like a only if what old message at I is not a space. Okay. Else my new message, I would just add a space to it. Equals new message plus a space. Okay. And that would take care of looking at a space, or it could take a look at looking at any other characters that I don't necessarily want to decode for this. Right? And I just have to run that loop, and eventually when all of this is done, I can just return a new message. Okay, so that might be something that we could pretty easily code and test out for some of our questions here. So why don't we take a look and see if we can get that part to work before we do anything else. All right, so I got my IDE up here, and we are going to be trying to code this mapping function here. All right, so we'll call it, say, maybe map message. And remember, I'm sending in an old alpha, a new alpha, and an old message to it. Okay, and I'm going to need my main program here. A couple different things we're going to do with it. We're going to test the encoding, and we're going to test the decoding aspect of it. But oops. But either way, okay, we're going to need those new alphabets. So we'll have our normal alpha, which would be spare you me singing the ABCs, and we've got our shifted alpha, which I said started with F. And then we restart. DE. Okay, so those are our predetermined alphabets just for the testing purposes. Okay, and make sure we call main after that. So basically what I'm going to do is if I'm going to have a plain text message. So my plain text, we'll do that first. So that was what, may the force be with you. Okay. And my cipher text would be would call map message, and it's going to return the new message to me, and I would send to it my normal alpha, my shifted alpha, and my plain text message. Okay. And then print the cipher text afterwards. So this will be the code to encode. If I wanted to decode, okay, I would have a cipher text. So I'm going to use the other example to show me the money one. So it was XMTB, RJ, YM, J, RT, SJD. Okay. And then my plain text would be, I would map the shifted alpha is my old one because it's already been scrambled up. My new alpha would be my normal one because I'm shifting back or changing back, and I would be sending cipher text to it. Okay. And I would be printing the plain text. Okay, so yeah, that's how that would work. I just have to kind of fill in the code for the map message, which we already talked about. So let's see if we can get this to work. So what do we have to do? We need a new message that was a blank string, and we need a loop. I'm going to use I as my counter, and it's going to go from 0 to the length of my old message. Okay, and then I'm going to, I need that if statement, right? So if the old message at I does not equal a space, then I find the location of that character. So old alpha, I search the old alphabet for the location of the correct character in the message. And then I create the new message with it. New alpha, at I, no, not equals, plus, not at I, at location. Okay. And if it was a space, then my new message was just my original message plus a space. And once it gets to the entire message, then I return the new message. Okay. So, in theory, when I run my program, what should happen is it should do this first, okay, and it should print out the ciphertext message so that we were using in the example, and then once it's done that, then it will map this to a plain text message, and it should say show me the money. Oh, one other thing, I forgot to make that a function. So here we go. Let's see what happens. Okay, so this output here is my encoded message, and if we go back to the screen that I had, okay, so may the force be with you, with a shift of 5 was RFD, YMJ, and you can check the rest, and that is encoding correctly. And then I took my ciphertext here and then decoded it with the same shift of 5, and it said show me the money. Okay, so there we go. So I have a mapping function that will do my encoding and decoding. I just now need to write and figure out how to generate the shifted alpha based on whatever shift I want. Okay, because here I coded it by hand just to test, but now I've got to write and figure out some code on how to actually create that shifted alpha based on the parameters of my problem. Okay, so now we need to look at how to find the actual shift value that we need before we can even start creating the shifted alphabet. Now, in this particular problem, it is saying that the shift value will be representative of the character that appears the most often in the plain text message. Okay, so we're going to write a function that finds the shift value. And we need to know all of the letters of the alphabet because we need to know what to search. Okay. And we need the message to search. Okay. So this will be our function that we need. So what we have to do is we have to search for each letter in our alphabet. So we need a loop. Say I is our counter, from 0 to the length of the alphabet. Okay, because I have to count how many A's, how many B's, how many C's, how many D's in the plain text message or the message. Okay, I suppose we could use this to go backwards too. So, and we know how to count. We've done an example with that before. Okay, so it's like what, message dot count. And then I put what I want to count inside the bracket. So if I want to count the A's, I put A. If I want to count the B's, I put B. But I have to count just the letters in the message. So not the message, in the actual alphabet. So I got to go through A, B, C, D. So this has got to be the alphabet at my loop counter. So alpha at I. Okay. So now we can treat this, now that we know the count, we can, couple options, I guess. You could store all of these in a list, and then we could find the maximum value of the list and the location that the maximum value occurred. Or we can just kind of use the loop and just compare to the previous value of the biggest count and figure it out that way, which is probably easier to do. So if we had some type of like largest variable starting at 0, and then we could say like if the count is bigger than the largest, then my new largest is equal to the count. Okay, so we've done that kind of algorithm before. And since it said ties go to the letters later in the alphabet, we should put greater than or equal to. So if there is a tie, it would choose the later letter. Okay, so this will actually find the number, like let's say in my example here, it looks like O is the most frequent because there's 2 of them. It would tell me largest would be 2. That's not what I want. I want the location, right, of O in the alphabet. That's really what I want, right? Because that's going to determine the actual shift value. So I need its location as well. So every time I find a new largest, I need to record where it is. So my location is the I value. Okay, and once it goes through the list, it will now find this. So this is really what I care about, right? That variable there. So I could return the location variable, and that would represent my shift. Actually, it needs a slight modification because let's say A was the biggest letter or the most frequent letter, then the location variable would be 0. And I don't want to return a shift of 0. A would represent a shift of 1. B would represent a shift of 2. So it's actually 1 more than the location in the list that I would have to return. Okay? Because our list starts at 0 instead of at 1, we need to return 1 more than that. Okay, so we should be able to test that in our IDE now. So we'll go back to Spider, and okay, I got rid of my my other testing because I'm not going to need it for this one, but we can try some new plain text messages. We're going to start with something simple maybe, right? So let's see if it works. So it should return a shift of 1 with this. But so basically what I would call is my shift equals shift value, and I would send the normal alpha to it because that's what I want to do, and I would send the plain text to it. And then I can print out my shift value. So I just need to write that function. So shift value, and I'm going to accept an alphabet, and I'm going to accept a message, and this function is just going to count and find the location of the biggest letter, or the most frequent letter. Okay, so I need my largest is equal to 0. I need my location is equal to 0, and I've got to go through each I said I, right? So for I in range from 0 to the length of my alphabet. Okay, so search through every possible letter, and then I count how many of each one of those letters are in my message. So alpha at I. and then I compare. So if my count is bigger than or equal to the largest, then I have a new largest, and I record the location. Okay. And then I have to return the location plus 1. Okay. So if all goes according to plan, this should tell me the shift value is 1 because A is the most frequent letter. Okay. And see, it did. Okay. And if I adjust this now, let's say if I had B is the largest, shift value of 2. If I had Z, okay, I have a shift value of 26. Okay, so that appears to be producing the correct shift value. And now all we need to do is be able to use that shift value and figure out the new alphabet. Okay, in this video we want to take a look at how we can create our new alphabet if we know the shift value. And this is actually really straightforward to be able to do. So let's say we had a shift value of 5, okay, that we've been using kind of before here. Okay, so how the new alphabet gets created is you just take the first, since it's 5, you would take the first 5 characters and kind of split your string there. All right. So what we would have to do is the first part of our new alphabet is everything to the right of that first. So this is your new part here at the start. So your shifted alpha is going to be this part here at the start. And then we would add to it the part that we had there. Okay. And luckily, Python makes it really easy to split strings like that, because, or splice, I guess splicing would be the correct way to look at this, because this section here, right, is the normal alpha from the shift value to the end, right? So remember we did splicing in the strings note. If I do the, I can go between a range, right? Between a shift value and something else. If I want to go right to the end, I don't need to put anything there. And this part here is the normal alpha from 0 to the shift. Okay. And if I just add those together, right, because I can do that with strings, I will get the new alphabet that I'm required. Okay, so that's pretty straightforward. We can test that really easily now. Right. So let's go back to our IDE. And we will start testing it. So maybe we'll have a shift, let's say is 5. Okay. And my shifted alpha will just be exactly what we just said. So the normal alpha at the shift to the end plus the normal alpha from 0 to the shift. Okay. And I could print out the shifted alpha for that. Okay. And oops, what did I do? Normal alpha. Okay, so there we go. So remember, that was a shift of 5, and that's exactly what we've been using before, right? The first letter would be A. So if we could test, actually, we could test all of them, right? So we could start with a loop, and we could say we could go from 0 to 26, right? And I guess I could say, instead of I would just go shift. Okay, so I would shift at 0. That was kind of silly, but okay, you can get the point. And actually they'll only shift to 25, but let's see what happens. Okay. So if I shift 0, okay, I get the same alphabet left over. Okay, if I shift by 1, the A gets shifted to B. Shift by 2, the A gets shifted to C. Okay, and then all the way down to the end. And if I went one more, remember a for loop stops one less than the number here. Okay, but I'm just getting back what I started with, so I actually don't need to go to all the way to 26. I actually don't even need to start at 0, I guess, either. Okay. Because it would be no shift. But there we go. So I can generate all the different possible keys to solve the shift cipher problem. So I guess I could use that then to write some functions to do my encoding and my decoding for the rest of this problem. All right. Because, so let's do our encode. And what has to happen. So to encode, we would need I guess I would need the alpha, the normal alpha. I'll just define it maybe in there. Don't need to define it in my main method. Basically, I'm just going to have this as like my main method. Basically, let's just let the user choose, I guess. So pick 1 to encode. Oh, I guess I need it. And pick 2 to decode. I'll get an input. So make your choice. Yep. And if choice equals 1, then we'll say get the plain text message. Enter the plain text. And then we'll call it. We'll just say encode equals, we'll just call it, or maybe encoded equals encode the message I send to it. Okay, and we'll print it. Okay, and elif choice equals 2. We'll do the same thing, but we'll enter the ciphertext. And we'll say decoded equals decode the message, and we'll just print that out. Well, I suppose you could have an error message here if it's not one of those choices, but okay, there we go. So there's my main function. That's pretty straightforward, right? And I'm just going to write the functions that do my encoding and decoding. So my encoding, I would need the message to it, and I need the normal alphabet to encode. And I'll find the shift value. Right? I'll just send the message to it because that's I send the message and the normal alpha, right? Yeah. Normal alpha and the message that was sent to me there. And then I create the new alpha. So the normal alpha, that was the code we just did, the shift to the end, plus the normal alpha 0 to the shift. Right. And then the new string is going to be the encoded message, would be I map the normal alpha, the new alpha, and the message. I guess this maybe message would be, maybe plain text would be better. Okay. Okay, there we go. And it should return the encoded message, right? So that's pretty straightforward function because we already did 90% of the work in those two functions. Okay, so we get the shift, we generate the new alphabet, we map the new alphabet to the old word, and come up with the new word, and then we send it back, and it will print it if that's the choice there. Now, the decode. Okay, we have a ciphertext that we're using. Okay. So I need that normal alphabet again there. I probably should just send it in, but I already started. Okay, I don't need to calculate a shift because I'm testing all shifts, right? That was kind of the point of the problem here. So it's that same loop I just had before. So in range from 0 to 26, and I basically create the new alpha for every shift. I can copy that. And then my decoded message was I map just the opposite. So I map new alpha, normal alpha, and ciphertext. And then, actually this is the nicest way to do it. Here, I guess, because I'm going to print out more than one message, so maybe I'll just call decoded and have it print inside the message here. Print decoded message. I mean, you could probably clean that up a little bit, but the video is getting a bit long here, so let's just get something that kind of works. All right, let's see what we can do. Okay, so let's encode. Apparently I'm wrong. Suppose I could convert that the way we should. Okay, so enter the plain text. So may the force be with you. Now, I'm not sure what it's going to print out as my encoded here, but let's see. So that would suggest that E was the most frequent in this sentence. So E, there are two of them there, and H, sorry, there's three E's. Okay? Something didn't seem right there. So there's three E's. So, and there's two of most of the other letters. So that's why it's giving a shift of 5. Okay, as we were expecting from the kind of example there. So that did encode correctly. Let's see if we can do one of the other ones here. So go back to my message, and I'll get that out of the way. So let's try to decode something here. So I'm going to decode one of my examples. So NDJ, WPS, BT, PI, WTAAD. Okay. And there we go. It's going to print out all the different possible cipher messages. I guess I don't really need to print out the first one. So that should be changing to 1 to 26 because it's no shift. But I looked through it all, and there was my original message. So you had me at hello. Okay. So that took a lot, right? Super long video trying to get through all of these functions, okay? But I have a nice piece of code written here, right? I use my problem-solving process to break this program up into pieces. I kind of thought about it ahead of time. I planned it out, okay? You really do need to do that. It's not going to work the first time, okay? You're going to try lots of things. It's not going to work. You're going to try again. That's okay. But this was a super hard problem to get through, and there we go.